So Headstart stands for Harmonized European Solutions for Testing Automated Road Transport. Some facts about the project. We started work in January 2019, and the duration is 36 months. That means we have around about 15 months to go. It is funded by the European Community. The budget is 6 million euro, and we are 17 partners working on the project. And would like to have a short, quick look at that. So it's from Spain, it's IDIADA, which is a coordinator of the project. It's also Pildo Labs and Vicomtech. From France, it's Valeo and Videcom. From Belgium, Ertico and Toyota. So we have from the Netherlands, RDW and TNO. Safer from Sweden. AST and EKA from Germany. From Austria, of course, Virtual Vehicle and 4A Systems as well. And from Italy, Iveco and Fiat Chrysler. So you see it's a well-balanced consortium, including research centers, technical services, Euro NCAP laboratories, OEMs, and Tier 1 suppliers. If you're interested in more facts and figures, please have a look at our website, headstart-project.eu. So this slide is quite important. It's about the objectives. Headstart will define testing and validation procedures of connected automated driving functions. And we are considering 3 additional topics, and that's why the project is quite special. So we are looking at some key enabling technologies, communication, cybersecurity, and positioning. We try to cross-link all the test instances. It's simulation, proving ground, X in the loop, and real-world field tests. And we are going to validate safety and security performance according to the needs of some 3 key user groups, that are the technology developers, the consumer testing, and the type approver. That's about the concept in the project. The left side, you see here some scenarios. We are using a scenario-based approach, but within the project, we do not develop scenarios. We use scenarios from some other project, like Pegasus from German, or the France project MOVE, or Ensemble from the Netherlands. But we enrich that scenarios with positioning features, with communication and cybersecurity features. Then we have a comprehensive procedure for the allocation of the test cases for each testing platform. So we have the choice for virtual testing, for proving ground, field testing, of course, X in the loop. And we try to achieve a very high correlation between simulation and proving ground results. At the end, we are going to harmonize these results and to try to evaluate and use these results for further improvement. And here, as you can see, there's a little bit a special feature, it's cybersecurity, and we will talk about afterwards about the cybersecurity issues within this concept. So this is about our first result. It's a methodology. Here again, you see the database. It's fed by field data, aerial data, accident data, simulator studies, and so on. We are using the 6-layer concept. And we are going to query this database and get the information about logical scenarios, and, parameter distributions. So we have a selection of relevant scenarios and stochastic variations. So we use the driving functions, information about the ODD, about the CATs, about technical maneuver behavior, and we strive for certain use cases where we get the functional requirements and the scenario description. And then we reach some concrete scenarios. And here again, we add the features of positioning, cybersecurity, and communication. Then we have to allocate the scenarios to the testing possibilities. It's a closed loop because we have some requirements to the testing facilities, and we are using the capabilities of these testing facilities. And then it's we proceed to the evaluation and the results. And we have to do one additional step for the cybersecurity assessment. So here about the next results. Based on this quite high-level methodology, we developed a process, and from this process we developed a very detailed procedure, a validation procedure. So the process is more about what we are doing, and the procedure is more about how to do that. And this procedure is documented in a very detailed way in the deliverable, and this deliverable is public. So if you're interested, all the deliverables in the project are public available. So we come to the conclusion. So far we have three main results. It's first about the state of the art. The assessment is public available. It contains information about worldwide projects and about functional requirements for automated driving, especially the key enabling technologies. Then we have the methodology as a second result, but we have to mention that it's a quite living process. So we are very interested to get in contact with experts to exchange our experience and to refine the methodology. The CATs have been considered in the whole process, and the methodology is harmonized and applicable for different databases. And the last result is a very detailed procedure, which allows us to continue with the actual implementation of the whole validation process. We try to intensify the cooperation with Open Scenario Extension and with the ASAM standardization group. So the next step is to use this procedure for development of a testing tool chain. So where we include simulation, virtual testing, and also field tests, and the harmonization of queries of external databases. So we will demonstrate this for certain use cases. Next year, it's a highway pilot, a traffic jam chauffeur, and a truck platooning. And again, we are really interested to get in contact with experts. We have 6 groups. You can read it here. And if you're interested, please join our expert groups. You can contact us about info@headstart-project.eu. So please stay in contact with our project. There are several ways. And thank you for the audience.